Okay, let me just share the slides. So let's see where we are. Okay, so yesterday we have started with a little bit introduction of operating system. We have talked about what the operating system can do, the components as you can see on the screen now, the components of a computer system, and what can the OS do, and how do you define an operating system. Okay, in chapter 1 and in overall this in general, you will be hearing two terms in this class. One is operating system, okay, and another one is the computer system. Okay, so computer system needs an operating system to run. Okay, so you can consider that a computer system is the hardware and operating system is the software. For the operating system to run, it needs the computer system, and for the computer system to run, it needs the operating system. So yesterday we looked at several types of computer system. Okay, so these are several types of computer system available in the market. You have the embedded computers, you have your workstation, you have your mini computer, you have embedded computers in your car, you have handheld device, you have mainframe, you have your mobile phones. So these are all considered as computer devices or computer systems. So what makes it different from one another is how the operating system works in each of these devices. The easiest is the computer system that you have, which is your laptop. How does it work? Is simply by you installing your operating system, and you are able to use all the functions provided in the operating system by the operating system. However, in an embedded computer system, okay, the computer system can only do limited functions. For example, as you can see here, the photostat machine, the ATM machine, it can only do certain functions, which is to give out money, or it can, which it's for it's for photocopying. Or you can see here there is a picture of the car payment system here, okay, parking payment system. So it's only limited to several types of function. But if you talk about computer system, okay, your laptop, your desktop, so that is more to complete system, and it needs an operating system to run. So today we will continue on what actually happens when your PC is being started, once your PC starts. Okay, so inside your PC, inside your computer system, there are two memories which you will always refer to. One is, or actually there are three. One is your ROM, okay. One is your RAM, and one is your hard disk. Okay, so a hard disk is where you keep all your files, your documents, and so on and so forth. But a RAM and ROM are totally two different things. Okay, the storage is a bit smaller, but in your RAM, you only keep programs or softwares which are running at the current moment. And inside the ROM, you only keep, or the operating system keeps, something which is called the firmware. The firmware is only used during uh, starting of the PC, starting of the personal computer. So when you're on your computer, the files needed is loaded from the ROM into the RAM, and it's being loaded. So what if you change your operating system? Let's say, for example, today you buy a laptop with Windows 10, Windows 11, and tomorrow you change it to Linux. Would that affect your ROM? No, your ROM would not be affected, simply because the ROM is stored inside, the files are stored inside the ROM, and these files are compatible to work with any type of operating system. However, if you're running on iOS, they would have a different type of ROM files, and you can only install, or you can only format and install back an iOS operating system. So you cannot have a Windows 10 running on iOS and either iOS running on uh, it, on a normal machine. Okay, so it doesn't work that way. Okay, so what is a kernel then in this slide? So a kernel, if you look at the structure, a kernel sits inside the operating system. So if you go back to the application software, what is the application software? Application software is a type of software which has limited functions, only to do certain types of program or certain type of function. Okay, so to run this function, you need an operating system. But to run an operating system, you need a kernel. So where are these files, the kernel files stored? The kernel files are all stored inside the kernel. Sorry, the kernel, the kernel files are all stored inside your ROM. So when you're on your PC, okay, when you're on your PC, when the PC is rebooting or being booted up, then these files will come out from the ROM and will be placed inside the RAM to start initiating. And once it's initiated, these files will disappear and the operating system files will take over. Okay, so this is how the computer system organization looks like. Basically, you have several types of hardware connected through what we say as the common bus. The bus is how each devices are connected between one another. If you compare a bus with your house electrical system, these are the wires which bring the electricity from one point to another point. But in the computer system, we use the bus to transmit data from one device to another device to another device. So each device has something which is called a controller or an adapter. So why do we need this controller or adapter? This control or adapter is mainly used to take care of each hardware. Meaning to say that this controller only takes care of all the hard disks inside your PC. Whereas the USB controller takes care of maybe the mouse, keyboard. Sometimes you plug in your headset to USB. So whatever is in USB control or whatever is plugged in through USB has its own controller, which is the USB controller. And the graphic adapter, what we can say is your graphic card, but each graphic adapter is connected to one monitor. So whatever input that is seen, whatever output that is seen on your monitor comes from the graphic adapter or graphic controller. And this graphic controller, the data that is passed in to your graphic controller or graphic driver comes from the memory. And where does these files come from? These files not only come from memory, but they come from the CPU. So always remember, whatever files that you need to process, okay, whatever file that needs to be processed by the computer system is always processed inside the CPU, and the data comes and is being stored inside your RAM. Okay, let's go on. So what can the computer systems do? This is not what the OS can do. What can the computer system do? Okay, the computer system is connected or can connect to any input-output devices, uh, and each devices, which is the hardware, has its own controller and its own buffer. If you see the blue one over here, okay, so and each of these devices are also connected to the CPU itself in the computer system. So any data which has been processed by the CPU is transmitted over the common bus to the respective device controller, and it comes out in the device itself. Example, let's say you do a multimedia presentation or you want to run a multimedia presentation. So the CPU runs it for you, and the data that is supposed to be transmitted out is transmitted over the common bus, okay, over the common bus right up to device controller, and the device controller has a local buffer where it stores the data and only then displays at the monitor. And the CPU, and it also provides CPU move data from and to the memory and the local buffers. And the device controller also informs the CPU that it has finished its operation by causing an interrupt. Okay, so this is how the device, any hardware, informs the CPU that it has completed what it needs to be done. Example, let's say the printer has printed, printer is a device, it has printed 10 pages, so now it has to report back to the CPU, informing the CPU, yes, I have printed 10 pages, and this is the notification. So that notification is what we say as interrupt. So there are several types of interrupt that the computer system can do. The main two interrupts are what we say as the interrupt vector and or interrupt driven, or what we say as the trap. Interrupt vector comes with a vector. Vector is a number informing the CPU what to do next. Interrupt vector usually comes from your hardware if and only if the hardware has a problem. Example, let's say you are printing 10 pages and at page 8 the printer has some problems. So the printer will send an interrupt vector to the CPU, informing the CPU that it has some problems. And what should the CPU do? The CPU will refer back to the vector. What is the vector? An address. What is inside the address? The address contains instructions of what to be done. Example, let's say the printer has some problems. So the printer will send an interrupt vector to the CPU. In bracket, let's say interrupt vector 4. So once the CPU receives it, it knows that there's some problems, and what should be done is inside location number 4. So it refers to location number 4 to find out what should the CPU do. Okay. However, if the interrupt comes from a software, let's say blue screen, or maybe there's some input issues or output issues from the software, then this is called either interrupt driven or a trap or execution. Okay, this has no vector. It's simply the CPU, sorry, it's simply the software telling the CPU there is a problem, but I don't know what to do. Please find out. Okay, then the CPU will find out what is the best solution to repair the problems of a trap or exception. Okay, always remember, interrupt vector is hardware, and trap or exception is a software problem. Okay, do you have any questions? Do I see any hands? Okay, tak ada. Alright, so what should be done when an interrupt comes? So this is where we say interrupt handling. How should the operating system handle each interrupt? One, okay, the operating system, once it receives the interrupt, it has to make sure that whatever the printer was doing or the software was doing previously needs to be stopped first and save that last information, okay, somewhere. Because let's say the printer was printing in page 7 and there's a problem. Okay, so it refers back to the CPU. First thing is the CPU must need to know what instruction was it doing before the interrupt happened. Okay, it was doing page 7. Okay, keep that in mind first. Next, determine what should be done. Is it an interrupt driven or is it interrupt vector? Vector means the address is given and I know what should be done. Interrupt driven, no, there is no vector, but I'll find out what's to be done. Okay, so once it has done this, only then it goes back and asks whatever instructions that was halted before this to be reprogrammed or redone again. Okay, so there are three steps. One, save the state. Two, determine either it's a trap, okay, or pooling, or it's an interrupt vector. Next, the third one is separate them and try to complete the interrupt. Once the interrupt is completed, restart back where you left off. Okay, so this is a picture showing the interrupt timeline. Okay, how long is a user program? And the user program goes in a straight line, meaning everything is smooth. Once an interrupt happens, it goes down here, and once an input output happens here, the input output goes up and down, up and down, up and down. Okay, so once an interrupt happens, what should the operating system do? First and foremost, it must keep whatever last instructions performed by the software or hardware. So where does it keep these instructions? It keeps it inside a device status table. What is this device status table for? Device status table keeps the status of all the devices inside your PC and to indicate to the operating system at what state it is. Is it printing? Is it idle? Is it not idle? Is it an error? So this is what it happens. Okay. A system call, on the other hand, is how the operating system responds to each and every request by the user. User. Who is the user? User can be you or me, can be the printer, can be the scanner, anyone using or anyone requesting information from the computer system. Right? Next, we also have something which is called the direct memory access. What is direct memory access? We'll cover here in a short line, but you will learn this more in chapter 2. A direct memory access is whereby you are downloading big information from the website, for example. In normal practice, all the information are being transported to the CPU first, and then the CPU will determine what to do, and then it will transfer back to the memory, and for the memory, keep it in the hard disk also whatsoever not. But however, if the data is big, then it bypasses the CPU straight into the direct memory access memory. Okay, this happens if the data that is being downloaded or transmitted is big and it does not need the CPU to determine what to do next. So this is called direct memory access. Next, we look at types of storage. So there is a main memory. When I talk about main memory, it means your RAM, or it can also mean it's only your RAM. Secondary storage, it means your hard disk. That's why we say it's a hard disk. Is non-volatile because your contents disappears once you off your PC. Magnetic disk, okay, is a type of storage device, and what we say as a SSD, okay, it's a storage device and it's non-volatile as well. So how you determine your storage capacity or hierarchy? Each type of storage device is determined based on speed, the cost of it, and whether yes, volatile or non-volatile. As you can see here, the smallest memory is the register. Register, cache, or sits inside the CPU. It's a type of memory, but the storage is very, very small. And it's not important. And you cannot just buy a register. It comes together with the CPU. Okay, memory, yes, you can buy. You can increase your memory size. Okay, and solid SSD, magnetic tape, optical device, and magnetic tape, or you can buy those. So the lower it goes down, yes, the bigger it gets size, but the smaller it also becomes. Okay, so this is the hierarchy. Cache, what is cache? Cache is something, is a type of memory, but it sits not inside the hard disk or not inside the RAM, but it sits inside the CPU. So sometimes when the data is big, the data needs to be frequently updated. Data from memory is kept inside the CPU, but is also kept inside the cache for it to be always refreshed and for it to be always used. Okay, in a computer system architecture, and now we're talking about the hardware back. There are two different types of system architecture, but today we are going to look at multiprocessor. What is multiprocessor? As the name suggests, it's multiple processors, multiple CPUs running at the same time. So it increases throughput. What is throughput? The amount of instructions able to be completed in one single time. Example, let's say you have an instruction, long programming code. If you run it on an old PC, it might take you, say, 10 minutes. But if you run it on a multiprocessor PC, it might take you only 2 minutes. Okay, if you're running too much of data now with big data and so on and so forth, so you need something which has a high throughput. Economy of scale, that means you can easily extend it. For example, like RAM. RAM is economy of scale because you can buy bigger RAM. Okay, you can increase the size. And increase reliability, meaning it will not easily be in fault, or it'll always be there. Okay, dia tak senang rosak lah. Okay, so in multiprocessor there are two types of system that we also look at: asymmetrical and symmetrical. What is the difference? So asymmetrical, okay, this one you can read it on. This is how DMA works. Symmetrical means the system only shares one memory. So inside your CPU, you have your registers, you have your cache memory, but your memory is all consolidated and all shared in a different location. So in this diagram, you have 3 PCs, 1 memory. So obviously the memory size is very big. So this is what we say as a symmetrical multiprocessing. Okay, symmetrical multiprocessing. We also have asymmetrical multiprocessing as well. Okay, that we will cover in the next class. All right. A clustered system is whereby you have multiprocessors, but all of it are connected through network cables. This is what you have in computer labs. Okay, so all of us are connected, but when you want to process anything, it's done individually. A clustered system works best in a network system whereby you can transfer data from PC number 1 to PC number 2, and everything is all connected just using your network system. Okay, I think that's enough for today because I have something else to do. We will stop here at slide number 27, 28, and we will continue back next class. In the next class, we will continue back until the end of chapter 1. Okay, do you have any questions to ask me?
So far, not yet, sir.
Not yet, yeah. Okay, no problem, sir. Okay, thank you very much. Please sign your attendance at UFuture and make sure you all sign your attendance. And inshallah, I will see you back next Tuesday morning, 9 o'clock. InsyaAllah by that time kita semua dah berpuasa. So I wish you all selamat berbuka pula, belum puasa pun dah buka dah. Selamat berpuasa, and insyaAllah I shall meet you in the next class. Thank you so much, and be good, be safe, and insyaAllah I will see you next week. Don't forget to sign your attendance in your future. Okay, thank you so much. Assalamualaikum warahmatullahi wabarakatuh.